At some time in the future, a space probe will plunge into a tunnel in space and time. One day, our universe will cool and die. Our only escape may be to risk a flight into a different universe. Perhaps the greatest question facing the human race is to discover where we came from and to find out what is our ultimate fate.
Every culture, every age has asked that question and tried to answer it.
It's one of the greatest adventures of the human mind to find out where we came from, where we are, and of course, in the end, where we're going.
Astronomy provides the basic information that each person needs to understand where he or she came from and where the human race is going.
Now, at the dawn of a new millennium, we are on the threshold of understanding how our universe began and how it will end. Cosmologists around the world are trying to unlock the origin and destiny of everything we see around us. One of this elite group is Bob Kirshner. He's on a journey to Cerro Tololo in Chile to measure if there's enough gravity to hold the universe together.
We've known for a long time that the universe is expanding and coasting along since the Big Bang. One of the questions has been how much gravity has been slowing down the expansion of the universe. Just like when you drive a car up a hill, you can slow down if you don't apply power because gravity's pulling back on you. We think that the expanding universe would be slowed down by the gravity, by all the stuff that's in the universe. One of the interesting things is that we've been able to do some work to try to measure that, and we found a surprising result. Not the one that we expected to find, but one that really turns the whole problem on its head.
Kirshner's team may have discovered answers that seal the fate of our universe. They've discovered that it's not just expanding, it's speeding up. Cosmologists now realize that to understand what the future may hold, they first have to unravel what happened at the beginning of the universe, at the start of time itself. In our daily lives, time is constant and dependable. It's almost impossible for us to imagine, but before the creation of the universe, there was no time.
We can trace back cosmic history to a stage when everything was very dense, very compressed, very hot. But the further we go back, conditions were so extreme that we can't really rely on any of our common sense intuitions. We can say that time, in the sense we understand it, didn't really exist before that.
So when did the clock start ticking? 12 billion years ago, there was absolutely nothing. No matter, no space, no time. We may never know how or why it happened, but a seething mass of energy smaller than an atom grew from nothing. inside the Big Bang, the birth of our universe, a violent fireball of unimaginable heat. For England's Astronomer Royal Martin Rees, understanding the Big Bang is the key to the universe.
Something that was literally originally only the size of a single atom or smaller, expanded to be large enough to encompass everything in our present universe.
Only the minutest fraction of a second had passed. But all of this was puny compared to what was about to happen. Propelled by a new surge of internal energy, the universe suddenly entered an incredible period of inflation. It expanded 100 trillion, 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 trillion times to the size of a grapefruit. Einstein's famous equation, E equals mc squared, told us that energy and mass were interchangeable. It gave us the knowledge to build weapons of mass destruction and the knowledge to understand how our universe was born. When a nuclear bomb explodes, a tiny amount of matter is completely annihilated and converted into energy. But in the Big Bang, the exact opposite happened. Pure energy was converted into matter. Approaching a millionth of a second old, the universe was brimming with energy, so intense that it was spontaneously converted into lumps of matter, and its arch-rival, antimatter. A titanic battle ensued. Subatomic particles annihilated each other, blow for blow, particle for particle. When matter and antimatter meet, they mutually destruct. This is the most powerful release of energy known.
If our universe started off with equal amounts of matter and antimatter, all the atoms would annihilate with anti-atoms, and we'd end up with a universe consisting just of heat and radiation, but nothing from which we and the stars could have been made.
But somewhere in this tiny blazing inferno, the process was slightly imperfect. There was more matter than antimatter. At the end of the battle, matter had won, and the universe was far from empty. Every time a particle of antimatter had been annihilated, the energy was converted into radiation. And that radiation is right before our very eyes. Don't adjust your set. Hidden in the interference on a badly tuned TV set is the energy signal left from the first second of the universe. The discovery of the Big Bang was one of the greatest scientific discoveries of all time, even though it was an accident. This is the horn antenna at the Bell Research Labs in New Jersey. Its unusual funnel shape was designed to collect faint radio waves from early communication satellites. It was being used for an entirely different experiment when it detected something truly remarkable, a discovery that would win 2 American scientists the Nobel Prize.
When I visit the horn antenna, I'm always reminded of the days back in the 60s when Arno and I were using it seriously. You know, it's amazing to think about, just doing your experiment and discovering the beginning of the universe, but there it is.
In 1964, Bob Wilson and his colleague Arno Penzias were using the horn antenna to search for natural radio emissions from our own galaxy. But as soon as they switched their giant earpiece on, it started humming. It was picking up weak but constant background interference. Wilson and Penzias had no idea where the signal was coming from. At first, they suspected nearby New York, but when they ruled that out, their suspicions turned on the local bird population.
There were a pair of pigeons living in the antenna. Once a week, we'd come up and disturb them. They'd fly away, but the next day when we were gone, they'd come back. So the inside of the horn was covered with white pigeon droppings. We got up in the horn reflector with a broom and swept it all out.
With the pigeons evicted, the two scientists were disappointed to find the interference was still there.
We looked in various directions. Sometimes we looked at specific objects, other times we looked at random parts of the sky, and every time we did that, we saw the same level, the same amount of excess noise. It was the same in all directions.
They began to realize that it could have a more dramatic origin. What Wilson and Penzias had stumbled across was a background of microwave radiation, a faint afterglow of the battle that defeated antimatter 12 billion years before.
The microwave background comes from the initial very dense and hot stage of the universe. And as the universe expands, the radiation expands with it. And just like anything else that expands, it tends to cool off. It came from the early stages of the universe, and it's just out there. If you go outside, it'll hit you on the head. You won't notice it because it's so weak. It's at such a low level that it's almost undetectable.
Every television set on Earth can detect the radiation from the Big Bang. Antimatter had been defeated, and the universe was still only a second old. Over the next 3 minutes, the explosions created the kind of matter we would recognize today: hydrogen and helium. It was still too early for the universe to shine. In the dark ages that followed the Big Bang, these elements would combine together and provide the building blocks of the first generation of stars and galaxies. The atoms created 12 billion years ago are still with us today. Since the Big Bang, the universe has continued to grow and expand. To understand just how big it has grown, we need to take an imaginary spaceship ride from the Earth to the edge of the visible universe. Our nearest neighbor is the Moon, just 250,000 miles away. At the center of our solar system, 93 million miles away, is our Sun. After crossing the center of our solar system, we continue our flight beyond the orbit of the Earth. The next planet out is Mars. Beyond the orbit of Mars is the asteroid belt. A billion miles away is the giant outer planet Saturn, almost 1,000 times the size of Earth. As we leave the solar system, we would pass one of our earliest interplanetary explorers, Voyager 1, launched in 1977 and traveling at a mere 40,000 miles per hour. Proxima Centauri and Alpha Centauri, A and B, our nearest stars, are 25 million miles away. Our solar system sits in the quiet suburbs of a spiral galaxy, the Milky Way, a star city containing over 100 billion stars. Every star we can see in the night sky lies within our own galaxy. This is deep space. Out beyond the Milky Way, 10 million miles from Earth, is the next spiral galaxy, Andromeda. Even traveling at the speed of light, it would take 2 million years to reach here. Andromeda and the Milky Way form part of a small cluster of galaxies called the Local Group. But stretching out way beyond the Local Group are much greater clusters of galaxies. If it were possible to travel fast enough for long enough and reach the edge of the known universe, this is what we would see. Uneven clusters of galaxies, a pattern that was predetermined in the very first second of the Big Bang. This is as far as our spaceship can take us. We are now 50 billion trillion miles from Earth. This is where science ends and speculation begins. Astronomers may never see what lies beyond here. This is where the secrets of the universe are hidden. For centuries, astronomers have been trying to locate our exact position by looking further and further across the vast expanses of deep space. For 400 years since Galileo first pointed his telescope at the sky, astronomers have not only been looking across the far reaches of space, but back in time. Because the light from distant objects takes so long to reach us, every telescope is a time machine. Even traveling at an unbelievable 186,000 miles per second, light takes a long time to cross space. Light reflected off the surface of the moon is already over a second old by the time it reaches us on Earth. Look up at Saturn, and you're seeing it as it was 1.5 hours ago. And we see Andromeda as it was when the first humans walked the Earth. Its light has been traveling across space for over 2 million years. Here at the Lick Observatory, Sandra Faber spent her early career unraveling the mysteries of the most distant galaxies.
The biggest telescopes on Earth now are taking us back billions of years into the past, 90% of the way back to the beginning of the universe.
View light from the furthest visible galaxies, and you're seeing them as they were over 11 billion years ago.
A galaxy is really like a city of stars. Just as there are billions of people on Earth or millions of people in a city, there are hundreds of billions of stars in a typical galaxy.
The universe contains over 100 billion galaxies. Like giant hurricanes in space, their resident stars spin around a giant central core. To see into the heart of the most distant galaxies would require a very special telescope. In 1990, the launch of the Hubble Space Telescope promised astronomers a view of the early universe they had only dared dream of. High above the Earth's atmosphere, this billion-dollar looking glass would have a totally clear view of the most distant galaxies. But the dream turned into a nightmare. Soon after it was launched, they discovered that the mirror was misshapen. It saw everything out of focus. One of the repairmen sent up to fix the stricken telescope was astronaut Jeff Hoffman.
It was unbelievably embarrassing for NASA and for the astronomical community. I mean, I had astronomer friends who that summer when they were on holiday and people asked, well, you know, what do you do for a living? They didn't even want to say I'm an astronomer because the first thing everybody would say, oh, the Hubble telescope, ha ha, you know, it was a big joke.
First, the crew of the rescue mission had to capture the crippled telescope.
Hello, Jeff?
Then execute a repair mission unprecedented in the history of space flight. Spread over 5 days of spacewalks, they repaired the faulty optics. The replacement parts fitted perfectly. The problems came when Hoffman attempted to close the huge access doors.
Lo and behold, they did not close. And I worked, I went up to the top of the doors, I went to the bottom of the doors. But what we figured out was that we could use an extra tool which had a little strap and wrap that around some bolts to gradually winch the door close. We ended up spending over 8 hours outside, which is the second longest spacewalk that's ever been done.
At one point in the mission, they even had to dump a damaged solar panel overboard. With all the repairs completed, the cosmological community held its collective breath to see if the most expensive telescope ever built would finally deliver what its designers originally promised. This is what Hubble saw. The images they received were beyond anyone's wildest imagination. Free from the distortion of the Earth's atmosphere, images captured by the Space Telescope left even the most hardened of cosmologists in awe. Hubble captured the final moments of a star's life when it explodes and blows off layers of gas and dust. It also captured interstellar nurseries of newly born stars, each one as varied and unique as a human fingerprint. And dark pillars of cosmic dust more than 1 million miles long, ready to spawn a new generation of stars and planets. But Hubble's true moment of glory was still to come. The mission controllers pointed the telescope at a distant, empty patch of deep space and waited. Over a period of 10 days in 1995, emerging across the coldness of space, the Hubble Deep Field image revealed a tapestry of distant galaxies. This was the furthest back in space and time we had ever seen.
To point the telescope for hundreds of hours and let this light that has traveled for 10 billion years slowly dribble in and accumulate. When you see so far back and see so many galaxies and imagine that the sky is filled with them, billions of galaxies, that's like 10 galaxies for every person on Earth, something like 50 to 100 billion galaxies, and each one of them containing 50 to 100 billion stars, say. That's an enormous number of places where there might be planets and life and very interesting things going on in the universe.
Powerful computers have turned the real galaxies of the deep field image into a remarkable 3D journey to the edge of the universe. In the foreground are mature galaxies like our own. Further back in time are younger, energetic galaxies. But beyond here, the structures begin to thin out. This is as far as we can see. This is the edge of the visible universe, over 90% of the way back to the beginning of everything. Faint galaxies that were formed just 1 billion years after the Big Bang. Beyond these galaxies, we can see nothing. We're entering the universe's dark ages.
Sometime, a few 100 million years after the Big Bang, this dark age must have ended when the first stars were born. And so the universe lit up for the first time, perhaps 500 million years after the Big Bang, and it's been lit by stars ever since.
The universe is so vast, some astronomers have decided to make a map of exactly where we are. Just as Galileo tried to make sense of our place in the heavens, here at Apache Point, New Mexico, a group of astronomers are trying to locate our position by constructing the biggest map that anyone has ever seen. Built specifically to map over 1 million galaxies, this is the home of the Sloan Sky Survey. Over a period of 5 years, astronomer Jim Gunn and his colleagues are about to start mapping our exact position in the universe.
We're in a galaxy, which is not a particularly remarkable galaxy, but this 3D picture that we will make of the nearby universe tells us how we fit into this vast scheme of things that is the universe, and I think will give us a much better idea of our place.
By systematically scanning the entire night sky from a site high above the desert floor, the results will be plotted not as a two-dimensional route map, but a fully interactive three-dimensional guide to the universe.
If you think about that from a kind of cinematic point of view, one could take this map very easily, put this map on a computer, and enable you to rotate the map, to fly through space, if you like, to look at our galaxy from outside, to look at the other galaxies around us from the other side, and take not only from any angle you want, but from any place in this map, and look out and see what it's like to be somewhere else in the universe than what we are, which is, of course, what you see in science fiction films all the time, but you will actually be able to do it with the galaxies that are there.
Jim Gunn's survey is an ambitious project, and it's only just beginning. This is how the final map may look. It's a computer simulation of superclusters of galaxies massed together in giant blobs. You are here. This would be the position of our planet, our solar system, and our own Milky Way. But on this scale, it would be impossible to see us or even any of our neighboring galaxies. This is a map of everything we can see. Everything in the universe, all the visible stars and galaxies, were born in the same furnace, the Big Bang. A ball of intense heat still cooling as it continues to expand. Cosmologists are not only confident that they have unearthed the universe's past, but that they can also predict its future. Space, like the surface of hot-blown glass, cools as it expands. Just as flecks of color embedded in the glass move further apart the more it stretches, so do the galaxies. Space is expanding in all directions at once. Modern cosmologists are now trying to measure if this expansion will continue forever. How will the universe end? The key to the future of the universe was discovered long before modern astronomers built their giant telescopes. Back in the 1660s, when Sir Isaac Newton had an encounter with a falling apple and discovered gravity. Newton formulated laws of physics which formed the basis of modern science. Gravity may be the weakest force, but it's the force that holds the planets and the stars together. After Newton, perhaps the greatest scientist and mathematician of all time was Albert Einstein. Einstein had been an unremarkable student, and his first job was as a clerk in the local patent office. His general theory of relativity, announced in 1915, explained for the very first time how everything within the universe interacts: space, matter, even time. His calculations told him that the stars and galaxies should exert a gravitational pull on each other and should eventually collapse together in a catastrophic fireball. But they hadn't collapsed, so to make his equations work, he invented a special repulsive force. But it was a makeshift solution, and deep down, Einstein knew it. Then, a decade later, along came a man with the solution to Einstein's puzzle. Here, at the Mount Wilson Observatory in California, Edwin Hubble took the first steps towards forecasting the fate of our entire universe. Hubble was a World War I veteran and a brilliant lawyer. When he turned his renowned skills to astronomy, he came up with a remarkable discovery that would change the way we view the universe forever. He made the astronomical discovery of the century, that the universe was expanding. 75 years on, measuring the precise speed of that expansion is the job of astronomer Wendy Friedman.
What Hubble found was that almost all galaxies appear to be moving away from us. And this led to the idea that the universe is expanding. Here was evidence for the first time that the universe was actually in motion, that galaxies are moving apart. What that means is that you can essentially extrapolate backwards in time. It's like running a film in reverse. If galaxies are expanding now, then at some time in the past they must have been closer and closer together. And what that implies is that sometime early in the history of the universe, galaxies would have been much closer together. The matter in the universe would have been much denser and much hotter. And this gave rise to the idea of a Big Bang universe.
Hubble's revelation stood the astronomical community's understanding of the cosmos on its head. He'd used the same technique that police forces around the world use today to catch speeding motorists. Hubble used the astronomical equivalent of a police radar. Instead of using radar signals, Hubble measured the light that came from distant galaxies. He knew that their color would be slightly altered if they were traveling towards or away from us.
If an object is moving away from us, then the light from that object will be shifted toward the red part of the spectrum. If an object is coming towards us, the light will be shifted toward the blue part of the spectrum.
By determining just how much the color had been changed, Hubble could work out how fast a galaxy was traveling. It's an effect known as the Doppler shift, and it applies to both light and radar. Hubble found that all the light from all the galaxies was shifted towards the red part of the spectrum. They were traveling away from us at an incredible speed.
There have been dramatic improvements in the technology since Hubble's day, and we now have the advantage for the first time of being able to get outside of the Earth's atmosphere. That is, we can go to space, use the Hubble Space Telescope, named after Edwin Hubble, to measure distances to galaxies.
Modern astronomers have calculated that we, along with all the contents of our own galaxy, are traveling away from the nearest cluster of galaxies at 1,000,000 miles an hour. By the end of this program, the whole universe will have expanded 1,000,000,000 miles in all directions. Wondering if there is enough matter in the universe to stop it expanding is a prime concern of Professor Stephen Hawking. Born 300 years after Newton, Hawking now holds Newton's old job at Cambridge University. Hawking already knows that the visible galaxies do not produce enough gravity. He now suspects that the universe is full of invisible dark matter.
If the universe continues to expand forever, everything will burn out and decay. The amount of matter we observe in stars and gas clouds is only about 10% of what is required to stop the expansion of the universe and cause it to collapse again. However, there might be other dark matter that we can't see, but which can still affect the expansion of the universe.
Dark matter is everywhere. The reason we can't see it is because of its size. Particles of dark matter are so tiny they can pass through anything. Neil Spooner and a dedicated band of astrophysicists are attempting to trap dark matter particles called WIMPs, weakly interacting massive particles, a mile underground at Bulby Mine in England.
It just makes up so much matter, so much of the universe. It's at least 90% and probably 99%. If it wasn't for this material, our galaxies would just fly apart. We believe that dark matter is composed of elementary particles that arose in the Big Bang, and they're around us all the time and they're passing through us all the time.
Neil Spooner and his team feel sure that any particles that could penetrate through 5,000 feet of solid rock would be dark matter. The team are attempting to record collisions between particles of dark matter and the atoms in a light-emitting crystal. But it's a long vigil that requires an unusual level of patience.
Occasionally, like about once a day, you might get one interaction. In other words, the particle comes in, strikes an atom, it recoils, and it produces a little burst of light, ordinary visible light, which we can detect with our instruments and then amplify and record into our computers.
It will take years, but if their equipment successfully detects dark matter, Spooner's team will have discovered the invisible 90% of our universe. But this may not be enough. There may still be too little gravity to stop the universe expanding for eternity.
It could be that the universe will basically expand forever and simply dissipate, and eventually will end up with a, if you like, a soup of rather boring atoms and dark matter diffused around, and it'll be a sort of slow death and on into infinity, and that'll be it.
For some, the challenge of predicting the fate of our universe is compulsive. Their passion for cosmology often turns into a lifelong obsession.
There are a lot of people engaged in trying to find out what the universe is, and I think it's mostly the same kind of curiosity that kids have when they're 6 years old or 8 years old. It seems to get beaten out of them in school, but we're sort of the ones that, I don't know, the schools didn't affect or something like that. We're still asking those same questions and still trying to get answers to them.
Here at Cerro Tololo, cosmologists have made a startling new discovery. Bob Kirshner believes that dark matter may not be holding the universe together at all. They're forecasting how the universe will end by observing one of the most violent cosmic events, stars that explode in distant galaxies with unbelievable ferocity when they reach the end of their life, supernovae. From the brightness of these explosions, Kirshner and his team can tell if a galaxy is near or far away. They measure the distant supernovae as markers to help them work out how fast the universe is expanding. Like Edwin Hubble, they're using the light from distant galaxies to get an accurate fix on the universe's rate of expansion. They thought they would be measuring how much the gravitational pull from dark matter was slowing the expansion rate down. But what they have found has stunned the cosmological community.
Well, maybe it's the other galaxy.
Rather than slowing down, the universe is speeding up. The galaxies are moving apart faster than ever before. Dark matter is not powerful enough.
See, but it looks to me like there's still something there at the location that was there, right there.
Scientists now believe that the universe will not collapse in a catastrophic fireball, nor will it coast on serenely. Instead, its contents will speed apart faster and faster until lost in the vast blackness of space.
So if the picture that is coming from the supernovae is really right, the universe will expand forever. In fact, sure. Now, this is really not anything to worry about, even though it is a kind of a bleak future of an empty, cold, dark universe.
What Kirshner may have discovered is a remnant of the original Big Bang. The inflation that started in the very first second of the universe is taking off again. Our universe is cooling and dying. In 1 billion years from now, our first unmanned spacecraft like Voyager 1 will leave the Milky Way and drift unhindered through the universe. As the universe reaches middle age, even the longest-lived stars will start to burn out.
Our sun has about 5 billion years of life left, and very few stars will still be shining 10 billion years from now. The dead stars will still orbit around the center of the galaxy, but their collisions will gradually cause most of them to fall into a giant black hole at the center.
Suppose we look ahead to when the universe is 100 billion years old. Then it would be a rather dull and dark place, because all but the faintest and most slow-burning stars will have died, so the universe will not only disperse, but all the galaxies will get fainter.
As the universe expands with age, gravity will lose its precarious grip. If you could be there to witness it, you would see absolutely nothing. Is there anything the human race could do to flee from such a dark fate? Could we escape into another dimension, into another universe?
The best ideas that people have come up with do suggest that maybe our Big Bang was not the only one, and that the inflation which led to our universe may have happened elsewhere, maybe an infinite number of times, in some grand eternal cosmos.
If other universes do exist, could we ever find a way of traveling into one? Wormholes are another prediction of Einstein's theories. Here, space is so twisted that it forms a tunnel from one universe to another. Even if these hypothetical holes in space and time do exist, entering a neighboring universe could be unwise. Travel into one where the laws of physics are even slightly different from our own, and you'd cease to exist at all.
Even though we have very small brains and we lead very brief lives and so on, the fact is we're able to understand where we are, and because we can use instruments like the big telescopes, the physics that we learn on the surface of the Earth, and the ideas that people have had over the last few centuries to build up a coherent picture. And I think we should be proud of that. We've done pretty well.
I feel it's been a great privilege and a huge amount of luck to be present to witness an important science like cosmology hit its peak.
In some way, creatures like us, and there probably are many, are the consciousness or the intelligence of the universe. It's almost as if the universe invented a way to know itself.
After centuries of gazing at the heavens, scientists now know that everything in our universe was born 12 billion years ago. Before the Big Bang, there was nothing. This violent explosion gave birth to everything we can see. Galaxies, stars and planets, even life itself.